by using De Moivre's theorem, prove that 1 cos 2 theta is equals to cos squared theta minus sin squared theta. Then the second one, sin 2 theta is identically equals to 2 sin theta cos theta. So how do we go about it? Proof. So actually, the De Moivre's theorem actually makes us to understand that, yes, if n actually belongs to the set of positive integers, then cos theta plus I sin theta, or raised to the power n, will be the same as, we'll take this n and multiply with the angle here. This will be cos n theta plus I. Take this and multiply this. This will be I sin n theta. And from what they want me to prove, it shows that n is going to be 2. So if n is equals to 2, then we are going to have cos theta plus I sin theta raised to the power 2. Yes, it will be identical. It will still be the same as this 2 times n. This will be cos 2n plus, then we'll take this one, I sin, then 2 times n will be 2n. Then I'll need to open this. Yes, opening this means multiplying it by itself 2 times, which will be cos theta raised to the power 2 will be cos squared theta. Then I'll have this times this is going to give me, this times this will give me I sin theta cos theta. I multiply it the second time again, so that will give me plus 2I sin theta cos theta. Then I sin theta raised to the power, I itself, I is square root of minus 1, so I square is going to be minus 1. So now this will give us I square will be minus 1, which is minus. Then sin theta raised to the power to give us sin squared theta. Sin squared theta. So this will still be identically equals to cos 2 theta plus I sin 2 theta. So from here we can take the real part together, because a complex number has 2 parts, the real part and the imaginary part. So